Okay, and now we're on week 2, and this week we're going to look at different types of arguments, and in particular we're going to look at deduction and induction. These are the 2 basic types of argument, and we'll be looking at different examples of each type.
Welcome back, everyone. So it didn't put you off entirely last week then? Difficult though it was, I'm sure it was difficult. Let's do a quick recap on last week so we can remember where we were. If you remember, I said that arguments are sets of sentences such that one of them, the conclusion, if you remember, is being said to be true, and the others, called the premises, are being offered as reasons for believing the truth of the one, or reasons for believing the one. Okay, so that's what an argument is. And I said it was important to distinguish arguments from 2 things. Firstly, sets of sentences that aren't arguments. And if you remember, there are 2 sorts of sets of sentences that are not arguments. Can anyone remember what they are? No, an assertion isn't an argument. An assertion is the second thing from which you should distinguish arguments. So I said that there are 2 sets. I think you misunderstood my question slightly, whoever it was then. So there are 2 things from which you distinguish arguments, but the first one is sets of sentences. And I said that there are 2 types of sets of sentence that you need to distinguish from an argument. Can anyone remember what those 2 types of sets of sentences were? Sorry? No, no. No, okay, maybe that's not a fair question. Okay, the first one is sets of sentences that aren't related at all. Do you remember I talked about Sears, Salt and Melbourne's in Australia? Well, until you add therefore and a bit of context, that's not an argument, is it? It's just 2 unrelated sentences. And the second type of sets of sentence you should distinguish from arguments are those that are related, but not as an argument is related, not as the sets of sentences that constitute an argument are related. So in order for a set of sentences to be an argument, it's got to be related in the sense that the conclusion is being said to follow from the premises. Okay? That's what an argument is, that one of the sentences of the set is being said to follow from the others. If that relation isn't being said to be there, then it's not an argument. The second thing from which you must distinguish an argument is a sentence. And can anyone remember how you distinguish sentences from arguments, or one way at least in which you would distinguish a sentence from an argument? What do you mean by premise there? A premise has a very particular definition. The definition is that a premise is a sentence that's being offered as reason for believing the truth of the conclusion. So what the question is here is, how do you distinguish a sentence or assertion from an argument? A sentence you could see as an incomplete argument, I suppose, but that's not what I was thinking of. There's no conclusion? Certainly there's no conclusion, nothing being, well, there is something being postulated if the sentence is being asserted, isn't there? Use of the words therefore and since? There's no relation, that's right, but okay, let me, oh, hang on, well, there's one more at the back there.
Well, aren't they just a simple statement?
Say that again?
Aren't they just simple statements?
That's right, this is just a statement, and a statement isn't an argument, is it? A statement isn't good or bad. Well, it could be, I suppose, couldn't it? A statement is true or false, and an argument is good or bad. Do you remember? Very important that you shouldn't call arguments true or false, because arguments can't be true or false. The only thing that can be a true or false is the sentences that make up the argument. What an argument is truth preserving. So if you have truth in the premises, then, and it's a good argument, then the conclusion will be true. But notice it's the premises that are true and the conclusion that's true, not the argument itself. The most the argument can be is truth preserving. Okay, so that's distinguishing arguments from sets of sentences and from sentences themselves. What we're going to do today is consider different types of argument. And we're going to start using some of the concepts that you've already mentioned this morning. So, there are two basic types of argument. There are deductive arguments and there are inductive arguments. This is a very basic type of argument because you'll see later there are lots of other types of arguments in these categories. But these two categories are the most important. These are the ones you need to get a grip on. Okay, let's look at deductive arguments first. Now, these are such that the truth of their premises guarantees the truth of the conclusion. So, if the premises are true, then the conclusion must be true. Because if it's a good deductive argument, it's truth guaranteeing. So here's a deductive argument. You'll be familiar with this one. We used it last week. It's Friday. Marianne always wears jeans on a Friday. Therefore, Marianne is wearing jeans. Notice that the conclusion of this argument is true. But neither of the premises are. So that should give you an idea that the argument is a good one, the conclusion is true, but actually neither of the premises are true. So this will be something we'll look at again when we look at what a good argument is next week. Relating to the real world, that's right. It's not Friday, therefore that premise is false. It's not true. You'll have to take it from me on authority that I don't always wear jeans on a Friday. I do happen to be wearing jeans today, but of course that's irrelevant because it's neither Friday nor is it the case that I always wear jeans on a Friday. But what's important about this argument is that it's deductive. It's truth guaranteeing, at least conditionally, upon the truth of the premises. Can you think of any situation, now really try and use your ingenuity here, let's see if we can get, in which that would be true. Okay, it isn't true, we know that, but we're assuming for the sake of argument that it is true. So imagine a situation where that's true and that's true for some reason. I always wear jeans on a Friday. Could that be false? Can anyone think?
You might have lost them in the intervening week.
Well,
That would be the exception to the rule.
well, wouldn't that make that not true?
Well, because that sentence implies Marion always wants to wear jeans on a Friday.
No, it doesn't. I may hate wearing jeans. That may be nothing to do with it. I may wear jeans as a penance on a Friday because I once did something really ghastly and said to myself, right, okay, from now on I'm always going to wear jeans on a Friday. So it doesn't say that I want to. Can anyone think of a counterexample? Okay, so it's true it would be Friday on that day, but would this be true? No, it wouldn't, would it? So what we've given there is a falsification of that, not a counterexample to the argument. Okay? Do you see where I'm getting at? What we're doing is we're distinguishing the truth of the premises from the truth-preservingness of the argument. Lots of us can think of situations where that's false or where that's false, but that's not what I'm asking you to do. What I'm asking you to do is to think of a situation where that's true and that's true and that's false.
It's impossible for that to be false.
It is, isn't it? Yep, you're quite, well, hang on, there are a couple of other examples here. Let's try one. So I'm on the moon or something like that. Very ingenious. I think what we're talking about is a situation where all these are, these two are true together. Do you see what I mean? And what you're giving me is one where it's not Friday, aren't you? Really, you're trying to make it not Friday somehow by shifting me out of a time zone in which it is Friday. No, it won't do. But we don't need to guarantee it because all we're doing, we're saying this is true, if this is true, and if this is true. We're not saying this is true. I mean, this is another very important distinction. When you're doing logic, you're not talking about the actual truth value of a sentence. Okay, so the truth value of that could be either true or false. Do you see what I mean? So that's the value of its truth. It's either true or false. And we're not saying it is true, but we're saying if it's true, and if this is true, this can't be false. And as you rightly said, actually, if these two are true, it's impossible for this to be false. It really is, isn't it? Well, if we're looking at an argument, we're asking ourselves two questions. The questions are, does the conclusion follow from the premises? And in asking that, what we're asking is, if the premises were true, would the conclusion be true? If the premises are true, would the conclusion be true? And if we look at these two premises and we ask that question, we're not asking whether the premises are true. We're saying, if they're true, would the conclusion be true? And the answer is yes. Can everyone see that? This is a deductively valid argument. It's truth-preserving, and therefore it's very, very useful, because we know that if the premises are true, the conclusion must be true. Now, in this particular case, this is not very useful because it's all hypothetical, but can you imagine if this was something that we didn't know but we were wanting to test, then we could say, okay, it's Friday, Marianne always wears jeans on a Friday, therefore Marianne is wearing jeans. Then if you see that I'm not wearing jeans, what do you know? One or other of these isn't true, exactly. So if you see that Marianne isn't wearing jeans, you know either that it's not Friday, that one's false, or that Marianne always wears jeans on a Friday is itself false. So you know either your hypothesis is false, or your observation is false. Sorry, you're quite right, or both. That's right. So if you have a valid argument, a deductively valid argument, the conclusion to which is false, you know that one of the premises must be false. And that's why truth-preservingness is useful, whatever the situation is, even if it turns out that the conclusion's false. Anyway, again, that's something we'll talk about more next week. The only thing that's important for now is that you understand what a deductively valid argument is. You understand that it's truth-preserving, that if the premises are true, the conclusion must be true. Okay, everyone happy with that? Let's move on. Okay, you should note, incidentally, that deduction is an either-or thing. Either an argument is deductively valid or it's not. Okay, there's no in-between there. It's one or the other. A good deductive argument gives us conditional certainty. Certainty conditional upon the truth of the premises. Well done. I can feel you're getting it now. Okay, a bad one tells us nothing. Because if the argument isn't a good one, if it isn't truth-preserving, then the conclusion could be either true or false, and we really don't know. Okay, so that's deduction. Let's move to induction. Inductive arguments are such that the truth of their premises makes the conclusion either more or less probable. Okay, it doesn't give us certainty, makes the conclusion more or less probable. Now, this means that inductive arguments can be either weak or strong. Okay, so here's an example of a strong inductive argument. The sun has risen every day in the history of the universe, therefore the sun will rise tomorrow. Okay, that's a strong inductive argument. Why isn't that a deductive argument? Sorry, what may not be true? Because arguments can't be true, of course, can they? This may not be true. Okay, but we're saying if this is true, then this will be true. So why is that not deductively certain?
The second sentence is not necessarily going to happen. It's not 100% certain.
Okay, so this could be true, and yet this false. And yet, this is a good argument. Yeah, good. Well done. That's exactly right. The hallmark of a strong inductive argument is even though you've got a very strong argument, I mean, if the sun has risen every single day in the history of the universe so far, I have no idea how old the universe is, but it's old, right? If the sun has risen every day in the history of the universe, then it's hugely likely that the sun is going to rise tomorrow, isn't it?
It's still wrong to put will, because you can't be 100% certain.
And then you say, but we can't be 100% certain, because who knows, the sun may explode tomorrow. Or maybe the law that ensures that the sun rises every morning actually has a bit of a dog leg in it. So it's saying, OK, what the law is every morning the sun will rise except on the 7th of October 2009, it's suddenly going to miss a day. And from then on, it's only going to rise every other day, OK, for the rest of the history of time. I mean, do we know that that isn't what the law is? Do we know that the sun, that the law that ensures that the sun has risen every morning in the history of the universe so far won't tomorrow miss a day?
So how could it be
That
so long that it could change?
We don't have that assurance.
Does that make the argument weaker?
Well, it makes it weaker, but it means that we haven't got certainty. This could be true and this false. But it's a different type of argument. We mustn't think that because deductive arguments are certain and inductive arguments aren't, that therefore inductive arguments are somehow inferior. Because actually they're dealing with different things. This is the sort of argument that science deals with, isn't it? You observe that nature has been like this all the times before, and then you extrapolate into the future to assume it's going to be like that in the future. So every daffodil you've ever seen in your life so far has been yellow. You're going to assume that the next daffodil you see will be yellow. There's another bad example, you see. But you see what I mean, I hope.
Why are Marianne's genes different in that case? Just because she's worn them every Friday up till now, why are we saying that she will therefore tomorrow wear them as well? If tomorrow, let's say tomorrow was Friday.
Because there's a... Whoops, sorry, I'm going the wrong way. This is the argument, right? An argument is a set of sentences. There are 3 sentences in this argument. The argument claim that's being made by this sentence is that if this is true and this is true, then this will be true. This will be true, okay? And this one, the inductive argument, is saying, if this is true, this will be true. Okay? Now, in this case, we can say, but there could be a counterexample to this. The counterexample might be that the sun explodes tomorrow, or that the law of nature has had written into it from the history of time that it'll change tomorrow, of all days. We know that this doesn't give us certainty, but it gives us a jolly good reason for thinking that this is true, doesn't it? I mean, I could give you an inductive argument that goes like this. In fact, let me give you one. Every time I've seen Marianne, she's been wearing earrings. Therefore, next time I see Marianne, she'll be wearing earrings. Okay? Now, is that a strong inductive argument? No. Well, it's not very strong, is it? I mean, the next time you see me, you might have come knocking on my door at 7 o'clock in the morning and I've just got up. And I don't wear earrings in bed. So the next, you know, we know too much about the world, about people, about earrings and things like that to know that that's a good inductive argument.
Could you put in another assertion that would make that deductive rather than inductive?
Well, let's go back to this one and notice that here we're arguing from this, not to it. Okay? This is a premise in our argument, not a conclusion. Okay? Whereas if we're looking here, oh, now I'm going the wrong way the other way. Oh no, actually what I was just about to tell you there isn't going to work. How did we get to this? Well, we've seen the sunrise every single day. We've seen lots of observations, and therefore we naturally extrapolate to a generalization like this. This is a different form of reasoning. This is inductive reasoning. And it's the same reasoning that causes us to say something like this. But in this case, the same reasoning isn't as strong. Here's another one. Who takes a lucky rabbit's foot into an exam if they ever go into an exam, who used to take a lucky rabbit's foot into exam. Who has a lucky red jumper or something like that? We've all had the experience of something's really nice happening to us, and we were wearing something or carrying something, and we think, you know, maybe I'll wear that again and I'll be lucky again, because we extrapolate from what's happened in the past to what's going to happen in the future. I've lost you, I can see. I'm looking at your faces and you've gone. Right. The only thing you need to remember is that a deductive argument, you've got certainty. Because if the premises are true, the conclusion must be true. In an inductive argument, you haven't got certainty, you've only got probability. Okay? This premise gives you probable reason to believe this. If this premise is true, this conclusion is probably true. Okay? But it's not certainly true. And if this premise is true, then this conclusion is not even probably true, is it? This is a very weak inductive argument. This gives you some reason for believing this, but not very much. Have a look at these. Go through. I'm going to give you a couple of minutes to do them on your own, so you really try and work this out for yourself. Decide which of those are deductive arguments and which of those are inductive arguments, and then we'll have a look at them together. So the sun is coming, well, actually, let's do them together. I think that's probably easier at this point. Let's have a look at the sun is coming out, so the rain should stop soon. Which is the conclusion of that argument? Oh, okay, well, right. Well, let's do it the canonical way, shall we, just so we've all got it. Which is the conclusion of this argument? The rain should stop soon. That's what we're claiming. And the reason we're giving for that claim is? The sun is coming out. So the premise is the sun is coming out, therefore the rain should stop soon. Now, does the truth of that premise make the truth of the conclusion certain? More or less. No. You can't have more or less certain, sorry. More or less probable, but not more or less certain. Okay. So is it inductive or deductive? Put up your hands if you think it's inductive. Yay! You see, I knew you got it really. Okay, good. That's an inductive argument. What about this one? Let's do it the canonical way. What's the conclusion? Right, I'm going to make you do the things that I make undergraduate, or used to make undergraduates do. Notice there's, can you make that a proper sentence? John won't be at the party. That's right. It's obvious what the sentence should be, isn't it? So, okay, the conclusion is John won't be at the party, and the premises are? Good. There are two premises here. One is Jane is at the party, and the other is if Jane is at the party, John won't be at the party. Notice that that's a complex sentence that's constituted of two sentences within the sentence. But you don't separate those two to make them two different premises, because the sentence being asserted is if Jane is at the party, John won't be. That's the premise. Good, okay. So we've got an argument that goes, if Jane is at the party, John won't be at the party. Jane is at the party, therefore John won't be at the party. Is that deductive or inductive? Put up your hand if you think it's inductive. Okay, put up your hand if you think it's deductive. Well done. Okay, so you are getting this. Okay, it's just sign up. The house is a mess, therefore Lucy must be at home. What's the conclusion? Just Lucy must be at home. The therefore just marks the conclusion rather than being the conclusion. Okay, Lucy must be at home. Premise, the house is a mess. Inductive or deductive? Put up your hand if you think inductive. Well done. Can you give me a counter example to that argument? Yes, that's right. Okay, so the house is a mess, but Lucy isn't at home. You've had burglars instead. Good, okay. Either he's in the bathroom or the bedroom. He's not in the bathroom, so he must be in the bedroom. Conclusion's obvious. It must be in the bedroom. And the two premises, either he's in the bathroom or the bedroom. He's not in the bathroom. Okay, deductive or inductive? Deductive. Well done. Okay, dog would have barked if it saw a stranger. It didn't bark, so it didn't see a stranger. Deductive, good. No one in Paris understands me, so my French must be rotten, or the Parisians are stupid. Which, I got this from a book. Inductive. Okay, it's difficult, that one, but it is inductive, you're quite right, because what's the conclusion? That's right, it's actually a complex conclusion, isn't it? My French must be rotten, all the Parisians are stupid, and the premise is no one in Paris understands me. So it may be the case that if that's true, these are true, but there are other reasons for nobody understanding me, aren't there, as well? Okay, good. So you have actually got it, even if we got tied up in a few knots there. No, I'm not going to say what it is. Right, logicians study deduction by studying valid argument forms. Now, here it's very important to distinguish form from content. Okay, arguments are deductively valid in virtue of their forms rather than their contents. Now, that's not true of all deduction, but it's true of most deduction. So let's have a look at what I mean here. All men are mortal. Socrates is a man, therefore Socrates is mortal. Okay? All actions that produce the greatest happiness to the greatest number, I got very bored writing it out, so greatest happiness to the greatest number. All actions that produce the greatest happiness to the greatest number are right, morally right, that is. That action produced the greatest happiness to the greatest number, therefore that action was right. Okay? Can you see that the form of those two arguments is exactly the same? Can you see that? So the content of the two arguments is quite different. This is an argument about Socrates and mortality, and this is an argument about morality and the greatest happiness to the greatest number. Completely different topics, completely different content, but each of the arguments has the same form. Can anyone try and write down the form? Tell me the form of that argument, the structure of it. Do you not know what I mean? No, okay. Let's do it together. All A's are B. S is an A, therefore S is a B. Did you get that? All A's are B. So let's do an interpretation here. A equals, or let's do it properly here. X is a man. X is mortal, S is Socrates. And the form of this is all A's are B, S is an A, therefore S is a B. Are you with me? Let me do it again. Can you see on the side there? So if this is the interpretation, I've just changed the words for symbols here, and the symbols are only letters. So A of X says X is a man, X is mortal, is B, and S is Socrates. So all A's are B. S is an A, therefore S is a B. You with me? So see if you can do that for the other argument. What would we have to say that A is there? Good. A is an action. BX is difficult. Go on. Produce, no, okay. All men are mortal. All actions that produce the greatest happiness, the greatest number, are right. Okay, so actually A isn't actions, is it? It's actions that produce the, no, not right actions, actions that produce the greatest happiness, the greatest number. So all men are mortal, and all actions that produce the greatest happiness, the greatest number, are right. You with me? So all A's, all men, are B's, mortal. All A's, actions that produce the greatest happiness, the greatest number, are right. Okay, and then the next one, that action produced the greatest happiness, the greatest number. You've got Socrates here as a particular thing, just as that action is a particular thing. Okay, and you're saying that particular thing is a man, i.e. falls into this class here. and therefore he falls into the other class too. Okay? So both those arguments have the form all A's are B, S is an A, therefore S is a B. Now, the point of this is just to get you to distinguish form and content. Can you see that an argument can have different forms and yet the same content? Different contents and yet the same form. Okay, so these are two arguments of exactly the same form, different contents. What's important about this is that logic is topic neutral. Once you've learnt how to do logic, it doesn't matter what you're doing it with or on, it's always the same. Logic is the same whether you're talking about the colour of chairs, whether you're talking about biochemistry, whether you're talking about the philosophy of time. It doesn't matter what you're talking about. If an argument is valid, it'll be valid by virtue of its form, whatever the topic is you're talking about. So logic is the ultimate transferable skill. If you've learnt logic, you can do it with whatever you happen to be talking about, whatever it is you're interested in, whether it's art history or fashion. Right, okay. Let's have a look at a few argument forms. Here's a valid argument form. If P then Q, P therefore Q. What's P standing in for here? What type of thing is it standing in for? Can anyone tell me? Good, or a sentence I was going to say, but a premise is even better. Yes, well done. So this is one sentence. What's this? No. No, not even that. It's oh, actually, that's a premise. Actually, that's a premise. That's only a sentence. Can you see why? That's right. Okay, so if P then Q is one premise, P is the other premise, and Q is the conclusion. So all we've done there, instead of thinking about actual sentences, we've just put in what are called sentence letters. Any letter will do, doesn't matter, just so long as you get the form of the argument right. Can you think of an argument that fits that form? Okay, just think for yourself now of an argument that fits that form. You could use one that we've already used. You could use one to do with the colours of the chair in this room. Quite difficult, but see if you can think of one. Go on, try it.
If I'm happy, then I can sleep. I am happy, therefore I will sleep.
Give her a clap. Well done. That's exactly right. Can anyone think of another one?
All miracles.
No, there's no all there. No, just...
the impossible cannot happen.
If the impossible cannot happen, then...
miracles are impossible.
No, you're not quite getting the idea here. Now, this will be happening to lots of you. This is not just you. The form is if sentence, then sentence, sentence, therefore sentence. And these two have got to be the same sentence, and these two have got to be the same sentence. So the form of it has got to be if P, then Q, P, therefore Q. Think of another one. Think to yourselves first, and then when you feel confident that you've got it, put your hand up and we'll try. This is really doing logic. So if you're finding it hard, that's right, it's in the nature of the beast. Are you? Well, sit down and think for yourself and then try again. No, you just said, oh no, you didn't. No, it's, okay, go on, you say one.
If blue chairs are comfortable and the chairs are blue, then these chairs are comfortable.
No, that was an if P and Q, wasn't it? And we're looking for an if P then Q. These words that are left are the logical words. And it's getting the logical words right, if, then, and, or, not, that's hugely important. Have you got one?
If he gets the bus, then he will be eco-friendly. He gets the bus, therefore he's eco-friendly.
Good, okay. If he gets a bus, then he's eco-friendly. He does get a bus, therefore he's eco-friendly. Good, well done. Paul?
If it rains, I raise an umbrella. My umbrella is up, therefore it is raining.
Oh, there's something wrong with that. What was wrong with it? Now, the sentences were great. Say it again, though.
If it is raining,
Okay.
I raise an umbrella.
Okay, so P is it is raining.
Yeah.
Okay, and Q is I raise an umbrella.
P, my umbrella is up.
Now, was P my umbrella is up? What was P? It's raining. So what do you need there instead? It is raining. Therefore, your brother. Do you see what you were doing there? Is you were committing the fallacy of affirming the consequent. Very common fallacy. We'll do fallacies next week, I think. But do you see? It has to be. You have to have the letters in the right order, because what you gave me initially wasn't a valid argument, but a valid argument could easily be made from it just by transposing those. Do you have another one?
I do. I hope this is right. If it's sunny, then I'll take my dog for a walk. It's sunny, so I'm taking my dog for a walk.
Therefore, I'll take my dog for a walk. Exactly. So P is, it is sunny. Q is, I'm taking my dog for a walk. And the argument is, if it's sunny, then I'm taking my dog for a walk. It is sunny, therefore, I'm taking my dog for a walk. Okay? Now, that has to be valid, doesn't it? If those premises are true, that conclusion has to be true, because any argument of this form must be a good argument, is deductively valid. Anyone else want to try another one?
If the postman strikes, then we will have no letters. Postman striking, therefore we have no letters.
Good, okay. If the postmen are striking, then we will have no letters. The postmen are striking, therefore we'll have no letters. So P is the postman is striking. No, not if, because the if, okay, the postman is striking, and Q is we will have no letters. So if the postman is striking, then we'll have no letters. The postmen are striking, therefore we'll have no letters. Good. Okay, one more, and then we'll move on.
If he's breathing, he's alive.
This is looking good.
He's breathing, therefore he's alive.
That's right. If he's breathing, then he's alive. He is breathing, therefore he's alive. Okay? Yeah, good. Okay, it's dead easy, isn't it, once you get the idea of it? And here's the... sorry, say that again? Like the third parrot? Oh, the dead parrot. Yes, I'm sure we could make one there. Here we are. If there are no chance factors in chess, then chess is a game of skill. There are no chance factors in chess, therefore chess is a game of skill. What's P here?
No chance factors in chess.
Good. What's Q?
Chess is a game of skill.
Good. Well done. Here's another argument. Okay, that was modus ponens, by the way. So you know how to do modus ponens. Here's modus tollens, the mode of denial. If P, then Q, not Q, therefore not P. Okay, if P, then Q, not Q, therefore not P. So this is saying, in effect, that P is sufficient for Q. Have I got it the wrong way around? No, I have got it the right way around. It's, what we're saying is here is that Q is necessary for P, and so if Q isn't the case, then P isn't the case. Well, let's have a look at the example, and then you can come up with your own. Actually, this example is wrong, because that shouldn't be in there. But let's do it. If the dog didn't know the visitor well, the dog would have barked. Okay? The dog didn't bark, therefore the dog did know the visitor. That shouldn't be in there. That's the one that I was saying I'd got wrong before we started. So if you take that not out, I won't draw on the screen there. So on your handouts, make sure that you take that not out on slide 16. Write that down now. I think it's 16. Yep. because that's incorrect. But do you see how that argument is valid? If it's true that if the dog didn't know the visitor well, the dog would have barked, it's a good guard dog, not guide dog. It didn't bark, therefore it must have known the visitor well, mustn't it? Okay? So see if you can come up with something of that form now. I'll take the example out so it's not confusing you. Have you come up with one already?
Yeah, if I have money, I'll go to the pub. I'm not in the pub, therefore I haven't got any money.
Well done. Fantastic. Absolutely right. So P is I have money. Q is I would be in the pub. Is that right? I'm not in the pub, therefore I have no money. If I had money, so the having money would be sufficient for you to be in the pub. Okay? But you're not in the pub, therefore you haven't got any money. Okay, anyone else want to have a go? Gentleman there.
If the sun is out, I will take my dog for a walk. The sun is not out, therefore I will not take my dog for a walk.
Good. You've got it, I think. Does anyone else want to have a go, or does everyone feel that they've got that?
That was wrong.
Well, was it? Yeah. Sorry, say it again.
If the sun is out, I will take my dog for a walk.
Okay, so P is the sun is out, and Q is I'll take my dog for a walk.
The sun is not out.
Ah. I'm sorry, those of you who saw the error, that's quite right. Okay, what should be here? I'm not taking my dog out for a walk, therefore the sun is not out. Yep, that's right, good. Okay, try one more then, as I got that wrong.
If I'm hungry, I won't concentrate. I can't concentrate, therefore I must be hungry.
Yes, okay. No, we had a not in the wrong place there, didn't we? How did it go again? If I'm hungry, then I won't concentrate.
I'm not concentrating.
Right.
I can't concentrate, therefore I'm hungry. No.
It would be... Hang on, we'll write this one down because there are nots in there that we need to get right because, as you see... Okay, so P is I am hungry. Q is I can't concentrate. Okay, notice that we've changed Q. Q is actually a negative here. That's where it's very easy to get tied up. So be very careful of this. Negatives immediately make things quite difficult. So, but never mind, we can do it. Okay, so Q is I can't concentrate. Now, not Q, therefore, is I can concentrate. Therefore, I'm not hungry. Are you with me? Do you see how that works? So you had the right sentences. You were just not using the negatives in the right way. I've forgotten who said this, so I'm looking at all the wrong people. But okay, one more on this one, because it's quite difficult. Paul. Oh, actually, we've had you, Paul. So did we have you before?
Not with these sentences.
Okay.
If I miss my train, then I'll be late. I'm not late, so I can take my train, or I haven't missed my train.
Good. Okay. If I catch my train, no, sorry, start again.
If I miss my train, I'll be late.
If I miss my train, I'll be late.
I'm not late.
I'm not late.
So I haven't missed my train.
Therefore, I haven't missed my train.
Can you say, or I've caught my train? Or do you have to use the same?
You don't have to use the same words as long as you... Now, this is actually the important point. You don't have to use the same words as long as the words have the same meaning. Or, do you see what I mean? But when you're learning logic, it's a very good idea to use the same words because it cuts out one area of complication. Do you see that? It just, why change your language when what it's going to do is confuse you? Keep things as simple as possible. This is quite hard enough without adding layers of complication in. Okay, good, you did that well. So what have I got? Oh, well, we've already tried that. Good, let's try another one. This is a disjunctive syllogism. P or Q, not P, therefore Q. Okay, have a go at that one. P or Q, not P, therefore Q. Okay? Oh, good. Look at you. Hands going up immediately now.
Well, it's either raining or sunny. It's not raining, therefore it's sunny.
Brilliant. Okay, it's either raining or it's sunny. It's not raining, therefore it's sunny. Good. Well done. One at the back there.
Something similar. It's either hot or cold. It's not hot, therefore it's cold.
Good. Well done. Anyone else?
And I'm either walking or driving. I'm not walking, therefore I'm driving.
Good. Okay, I think you've got it one.
Happy or sad, not happy, therefore sad.
Good. Well done. Okay, you've got. Notice that that works if you've got an exclusive or, because or is actually an ambiguous word in English. It can mean either or it can mean not both. And if this was either, this has got to be either or, hasn't it? Because if it were not both, you couldn't get the conclusion, could you? So that's where English can lead us astray a little bit, because English is itself ambiguous. Okay, here's my example. Either, this is actually a Bertrand Russell example, either we hope for progress through improving morals, or we hope for progress from improving intelligence. We can't hope for progress through improving morals, therefore we must hope for progress through improving intelligence. What this should tell you, incidentally, we've been looking at very simple ones, but actually these forms can be very complicated. One of the things I'm going to ask you to do this week while you're at home is when you read your newspaper, you listen to your television, or argue with your friends in the pub, or whatever you happen to do, I want you to try and identify arguments that come up. Whenever you hear the words if, then, and, or, not, if and only if, all these logical words, all, is, lovely logical words. Just you've got to be sensitized to them this week, because I want you to hear you. Every time you hear an if-then, I want you identifying the form of the argument in which you find it. Of course, it might not be in an argument, might it? Might be just a freestanding assertion. But have a look, see if there is an argument there.
I'm just getting a bit lost there, Marion. The second paragraph, is that an
Second sentence.
Is that an assertion?
Yes.
Who's making an assertion?
Each of the premises is an asserted sentence, a sentence that's being asserted, isn't he? So Russell is saying, you know, it's true that either we hope for progress this way, or we hope for it this way. Okay, there's no other option. We can't hope for it this way, he's asserting, therefore we must hope for it that way. Okay? What's incorrect?
That statement, because he assumes that intelligence has a higher...
Hang on, what's false here?
The concept.
So, is it the first premise? Let's start to use the language now. Is it the first premise that's false, or the second?
Improving intelligence.
Well, improving intelligence isn't a sentence. And it appears here and here, so what? Sorry, is that the false premise or that one?
Improving intelligence can improve morals because it's progress.
Right. I think I'm going to put this on one side, because A, we're not really looking at the truth of the premises, and B, you've got to take the premises as they are here. This is what's being asserted. So we're not saying this is true, or that this is true. What we're saying is, if this is true and this is true, then this must be true. Okay? These conditionals are very important.
Where does presupposition and biases come into identifying an argument?
Presupposition of what?
And biases.
We'll get onto that later on. So what I want to get us now, just sensitizing us now to deduction and induction and to the form of an argument. That's what we need to get today. Okay, let's move on. Here's another one, Leibniz law. A is F, A equals B, therefore B is F. I'll give you my example of that, because it's quite a difficult one. Jane is tall, Jane is the bank manager, therefore the bank manager is tall. If these are true, is that true? Has to be, doesn't it? Can't be anything else. Go on, think of a couple of examples of that one. Go for it.
Dogs bark.
No,
No,
don't think it's going to work.
I don't think it is.
Why is that not going to work? Let's see, why is this not going to work? Well, dogs bark doesn't have the form A is F. A is F is the chair is blue, Marianne is tall, the board duster is lost, etc. Not dog. You could say the dog is barking, but dogs bark is saying of one class of things that they fit another class of things, and that's not the form of that sentence, is it?
I don't know, but could you say chair is blue, this chair is comfortable, therefore this chair...
Go on. Not quite, no. What we've got here, this is a very interesting ambiguity here. Is a very slippery word in English. Is, you can have the is of predication and the is of identity. And your attempted argument there, and don't worry about this at all, this is a perfectly reasonable mistake to make, you equivocated between these two ises. So you said this chair is blue, is that right? And then you said this chair is comfortable. Okay, now this, well actually those are both ises of predication, aren't they? Whereas what we're looking for here is an is of identity, isn't it? A is B is the very same thing as B. So here we've got a predication, haven't we? A is F. A has a certain property. And here we have, and this thing A is the same thing as this thing B, therefore B is F. Okay, do you see how that has to be true? This is it's a law of logic, this one, isn't it? This is Leibniz law, it is a law of logic. If A is F, if Marianne is tall, oh, I'm just giving you the same example, so let me give it to you. If Jane is tall, and Jane is the bank manager, here's an is of predication, so we're predicating tallness of Jane, aren't we? Are you with me? And here we've got the is of identity, haven't we? Jane is the bank manager. Okay? If that's true and that's true, that has to be true, doesn't it? Because the bank manager is Jane, isn't she? Yes. That's what we're doing. We're looking at examples of deductively valid arguments. Arguments that are valid by virtue of their form. Okay, good. One last one, I think. Here's a syllogism. Now, this should be easy. All F's are G. A is an F, therefore A is a G. All Fords are cars. Okay. A is a Ford, therefore A is a car. Yep, well done. That'll do. Anyone else want to give one more example and we'll move on? Good, I see where you're getting to. Yeah, the grammar got a bit mixed up, but yes, okay. So all my clothes are wet. That pair of jeans is one of my clothes, sort of. Therefore it is wet. I see where you're coming from, okay? You've got one.
That's not my miracles again.
Okay, go on.
All miracles are impossible.
All miracles are impossible.
Resurrection is a miracle.
Resurrection is a miracle.
Therefore, the resurrection is impossible.
Therefore, okay, it works, doesn't it? Well done. We knew we'd get there somewhere. Incidentally, let me just give you a logical problem with that, just because I think you might enjoy it. You said the resurrection is a miracle, therefore the resurrection is impossible. There's something very logically fishy about true negative existential sentences, isn't there? If we say Pegasus doesn't exist, aren't we picking out something by the word Pegasus in order to say of it that it doesn't exist? In which case, how can a negative existential be true? See what I mean? Hamlet doesn't exist. You're picking out something, Hamlet, in order to say of him that he doesn't exist. Well, how can you do that? You shouldn't be able to do that. I'll just leave you with a little conundrum, because that's philosophical logic, and we're not doing that here. We're doing symbolic logic here. So now you know of two different types of logic. Okay, there's the canonical example for that one. all men are mortal, da-da-da-da. Now, I said that some arguments are deductively valid, but not in virtue of their form. Here are just a couple that are valid in virtue of their content, apparently. Deontic logic. Now, this is cutting-edge stuff. We know very little about deontic logic. Deontic logic is the logic of morality. Okay? What we're trying to look at is the area of discourse in which we talk about morality and say, how does it work logically? How can we get a valid argument form from talk of morality? Now, look at this argument. Lying is wrong, therefore we shouldn't lie. Now, that looks like a deductively valid argument, doesn't it? In other words, if that's true, surely this must be true as well. But if so, it's not true in virtue of its form, it's true in virtue of its... Well, could you say lying is wrong, but I'm going to lie? Well, we all know that you could lie, but if you truly believe that lying is wrong, you're also going to believe you shouldn't lie. Now, that doesn't mean you won't lie, but you'll feel guilty. You'll
doing wrong,
yeah.
shouldn't be done.
Madam, that's just what I said. I said, if you believe lying is wrong, then you're going to believe you shouldn't lie, aren't you? Do you think you could possibly believe that really believe that lying is wrong, and yet not believe that you shouldn't lie? Well, I think that if you find it, okay, if you lie, either you're going to feel shame, which manifests your belief that you do think lying's wrong, or you're not going to feel any shame at all, which manifests the fact that you don't believe that lying is always and everywhere wrong.
Being wrong is relative, isn't it? It's not
Oh! Don't get me on that. I'm not going to follow that one up at all. Oh, it's very important, yes, but we're not. But actually, we can safely leave it on one side here. If you're a Kantian, you think that this entails that. Incidentally, you might want to put another premise in here. You might want to say we shouldn't do things that are wrong. Someone want to do that? Okay. Kant would say if you did that, you're manifesting the fact that you think that you could believe that something's wrong without believing you shouldn't do it. And that just shows you don't understand what wrongness is. To Kant, to have the proper moral concept, which is that lying is wrong or something like that, you cannot believe that something is wrong without also believing you shouldn't do it. So it doesn't mean you won't do it, because we all know that we do things we believe to be wrong, but your belief that it's wrong will manifest itself as guilt, and if it doesn't, it manifests the fact you don't believe the first thing, that lying is wrong. So anyway, we're not going to get into morality. I just wanted to say there is a type of logic called deontic logic, and it looks at that sort of inference. And notice that we can't give you a form for that. That's the very meaning of the word wrong. There's something very special about the meaning of the word wrong, logically. Here's another one, modal logic. Modal logic is the logic of necessity and possibility. It's necessarily the case that there are no square circles. In other words, there's no possible world in which there's a square circle. If it's square, it's not circular, and so on. Therefore, it's not possible that there are square circles. So if P is necessarily true, then not P is not possible. Can you hear that? Your capacity for reason would follow that quite quickly. If A is necessary, then not A is not possible. Got to be the case, hasn't it? So again, we have a deductively valid argument, but it's not deductively valid, at least, actually we're a lot further on with modal logic than we are in deontic logic. We can do quite a lot with modal logic these days. And here's a bit of temporal logic for you. It's raining today, therefore tomorrow it will have been raining yesterday. Is that true? Okay, if that's true, then that must be true, mustn't it? Yeah, couldn't not. And that's because of the temporal logic, the way the logic of time works. Okay, let's move on. Getting a bit short of time here. We'll move on to inductive arguments. Now, inductive arguments, you remember, what's the hallmark of an inductive argument? Is if the premises are true, the conclusion might be true, probably is true. That's right. Okay. So the premises give us reason for believing the conclusion, but not, in this case, certainty. They don't give us conclusive reason for believing the conclusion. And that's because inductive arguments rely on the assumption of the uniformity of nature. That's what Hume called it, David Hume. The idea that the future will be like the past. So if we've seen the sun rise every day in the history of the universe, we expect it to rise tomorrow. If every time we've come here for Marianne's lecture on Monday at 2 o'clock, and Marianne's been lecturing at 2 o'clock, we'll carry on doing that. And if we come on the 7th week, we'll be disappointed, sadly. Okay, but it was quite a good reason for believing that Marianne would be lecturing on Monday at 2, that she has been lecturing at 2 every Monday for the last 6 weeks, but it's not conclusive, and so on. So we are, one of the biggest problems of philosophy, in fact, is how do we justify, can we justify this assumption? The assumption that the future is going to be like the past. Why should we think that the future has been like the past? Can anyone give me a reason?
Because it always has.
Exactly. Because it has always been the case that the future has been like the past in the past. So that's a circular. Yes, exactly. Every time you try and justify the belief that the future is going to be like the past, you'll find yourself arguing in a circle. The only reason we think that that works is because it always has worked in the past, therefore we assume it will work that way in the future. But human beings just cannot not argue like that. It's very interesting. I was playing with my cat the other day, and I noticed that it doesn't go in for inductive reasoning. If you do that with a cat, if you do it with a human being, the human being will keep going and expect you to keep going, but the cat doesn't. If you stop it, it stops. You don't catch it just slightly. It was interesting. Anyway, that's what inductive arguments rely on. Okay, tell me why this one. Tell me what it is we're assuming. Actually, this is a silly question. In fact, I don't like this question. I'm going to skip it. You can see why the assumption here is that because the sun has always done this, it'll always continue doing that in the future. And the assumption here is that because, in your experience, Marianne's always done this, in the future, Marianne will always do this. But our background knowledge comes in to say whether you think it's a strong argument or a weak argument. And I think you'll see that, given what we know about physics, about astronomy, about the laws of nature, etc., that is a strong argument. Given what we know about people and what they wear, that's a weak argument. But both of them rely on the assumption of the principle of the uniformity of nature. And there are subcategories within the category of inductive arguments. Here's one, an argument from analogy. A is like B, A is F, therefore B is F. Okay, A is like B. And notice these smaller lowercase letters stand in for particular things, whereas letters like this stand in for either properties or sometimes sentences, but I tend to use PQR for sentences and A for... oh, actually, that should be smaller case. Now I've started explaining it, that should be smaller case. Ah, scrub that. OK, A is like B, A is F, therefore B is F. You see how that works? And here's an example. The universe is like a pocket watch. A pocket watch has a designer, therefore the universe has a designer. You'll be familiar with that. Pascal's, no, it's not Pascal's. What is it? Paley, thank you. So the universe is like a pocket watch. A is the universe. B is a pocket watch. A is F. I've got this the wrong way round, haven't I? Here's your homework. Take that argument and put it into proper canonical, logical form. Come back and tell me where I've got that wrong, because I've got several quite interesting little errors in there. Some of them are just in the logic that I'm using, and some of them are, I've just transposed various things. It should be easy for you to see where I've gone wrong. Do it. And come and, if you want to come and check that with me next week, I'm very happy to have a look at it. Okay, do you want to come up with your own argument from analogy? Got time for one or two, perhaps? Hang on, there's someone over here who hasn't had a chance so far.
Universe is like a cabbage. A cabbage is green, therefore universe.
Yes, okay, that would do. One of your premises isn't true. Well, actually, no. Yes, one of your, well, I suppose a universe is like a cabbage, isn't it, in a, roughly so, shape-wise? Okay, well, that would work, yep. One more.
Trish is like Sylvia.
Sorry, say that again.
Trish is like Sylvia.
Trish is like Sylvia.
Trish is blonde, therefore Sylvia is blonde.
Good, yep, absolutely, that'll do. Good, we've got that. Let's have a look at another inductive argument. Can you see how that's inductive, by the way? Why is that? Why does that depend on the principle of the uniformity of nature? Well, it's again, we're assuming if one thing is like another in some ways, then it'll be like another in other ways. So we're assuming the uniformity of nature, aren't we? So if it's like that in one way, it'll be like that in another way as well. Here's another argument. An argument from authority. Einstein is a brilliant physicist. Einstein says relativism is true, therefore relativism is true. Of course, we could put in a different thing here. Einstein says pacifism is the right creed, therefore pacifism is the right creed. What have we done there? We've changed a good argument to a bad argument. Why is one good and one bad?
He's an authority here.
Because he is an authority on physics, that's right, and he isn't an authority on politics. But we'll be looking at good and bad arguments from now on, after next week. Okay, causal arguments. We looked at causal arguments briefly last week. Every time an A occurs, a B occurs. Therefore, A's cause B. Now, we have a huge tendency, and in fact, that tendency was manifested here last week in this very room, wasn't it? Where we assume that where there's a correlation, there's also a causal relation. Well, we know that that's not true, is it? We know that there can be correlations without causal relations, but even so, our evidence for causation tends to rest on a correlation. So if every time an A occurs, a B occurs, we'll tend to think that A's cause B's. So we argue from observation of a correlation to an assertion about a causal relation. And just to say quickly that causal arguments can be deductive or inductive, depending on whether we're arguing from a causal claim or to one. So A's cause B, there was an A, therefore there will be a B. Every time, every observed A has been followed by a B, therefore A's cause B. Which of these is deductive? Left or right? My left or that's left. Deductive, inductive. Yep, that's right. Can you? We're taking cause here. What we're saying, we're arguing to a causal claim, aren't we? From observations of correlation, and here we're arguing from a causal claim. Indeed, the conclusion of that one to a particular claim. Okay, so that's deductive. Well, you should be able to do this. Okay, that's deductive because if that's true, and that's true, then that must be true. Okay, this might be true and yet this be false. But even so, that is reason to believe that, isn't it? Okay, it's just not conclusive reason, whereas these are conclusive reason to believe that. Right. Your task for the week ahead. See if you can find in your newspaper, magazine, or a book, or wherever, I've said 4, but that's entirely arbitrary. Just see if you can find some arguments that fit the patterns that we've been looking at today. And you might also notice in your own behaviour, as you're talking to people, you'll find yourself, and I'm hoping to sensitize you to these logical words so that they can't go past without your thinking, ooh. So when you find yourself saying if, then, that's a particularly good one, if, then, or therefore, or since, or things like that. Catch yourself and try and work out what your argument was. Now, some of your arguments are going to be far too complicated to work out like that. At the moment, stick to simple ones. See if you can find yourself offering a simple argument. I said if you don't clean your room, then this would happen. You did not clean your room, therefore, you know, this sort of thing is what you're trying to find out for. And have a look and see if you can fit them into the forms that we've given here. Okay, and next week we're going to look at actually identifying arguments and setting them out logic book style. We've been doing that today, but we're going to do that with some rather more complicated arguments next week. We're going to look at arguments that you might make in the pub or in a newspaper or something like that. We'll look at a few magazine leaders and things like that. Sorry, newspaper leaders. That's it.